everyone, I hope you all are good and you all are practicing questions. Let us do this one. This is going to be a good check for our concept. So let's start with the question. Intensity of sunlight on the surface of earth is given and that is this much. Okay? And we have to neglect atmospheric absorption, meaning whatever light is coming from sun per second, all of that we are assuming that fall is falling on the surface of earth. It doesn't happen in the ideal case, but yes, here for the calculation we have to go with this assumption. We have to calculate what is of the sun, that is power of the sun. सो अगर आप देखो सन कैसा सोर्स है, आई मीन सिलेंड्रिकल, स्फेरिकल, इट इज स्फेरिकल सोर्स, राइट? क्योंकि अगर आप अर्थ पे हो, वी ऑल आर ऑन द अर्थ, राइट? सो अर्थ से जब हम सन को देखते हैं, सन लुक्स लाइक दिस, इट लुक्स लाइक it has a spherical shape, and this distance of sun from the earth is how much? That is equal to 1.5 into 10 to the power 11. This is not provided in the question, but it should have been actually, because in the exam they won't expect you to remember such thing. It will be provided there. Anyway, it is this one. ठीक है? अब देखो इतने distance पे light है. If P amount of energy is coming from sun per second, then what is the intensity over here? How you can relate it with this R? Distance of sun from the earth. So just let us take one basic thing. जैसे देखो, suppose कर लो तुम्हारे पास यहाँ पे एक source है, point source है, that is a spherical source is there. Light will come out of it in this way. In all direction, light will go out like this. ठीक है? So let's say you and your friend are standing. One is standing over here. Suppose you, and then your friend is standing here. And this is A is at a distance of R naught, B is at a distance of 4 R naught from the source. Now, who will feel light to be more intense? Obviously, you standing at point A, right? Because you're more closer. And as you will go further away with the source, you will feel like light is coming as more soft. It is more mellow, right? Done it? So, there is something to do with the distance between light, whoever is consuming the light, and the source. Done it? So, distance between these two will matter, and this is going to decide the intensity of light. How it will decide? Let's say power of light coming out from the source is P. So how you can define intensity at point A? So see here, P amount of energy is coming out from the source per second, and that light coming per second is falling onto which area? It is falling onto this dotted area. So this is a sphere, right? Done it? So this sphere will have an area of how much? 4 pi r naught ka square. So P amount of energy is falling onto this area per second. Intensity for A will be equal to P divided by 4 pi r naught ka square. This is energy falling per second per unit area. And for B, it will be equal to 1 by 16 P by 4 pi r naught ka square. It will be something like this. Similarly, अगर आप sun की बात करो, then what will be the intensity of light in terms of power? So that will be equal to 4 pi, and this is R. R is 1.5 into 10 to the power 11 का square. ठीक है? It will be this one, right? I is given. We need to calculate power. क्योंकि अगर आप sun को यहाँ पे center पे लो, जैसे sorry, orbit of sun and earth, I mean orbit of earth motion around sun is taken as elliptical, but for our convenience very often for calculation we'll take it as circular. ठीक है? And then we treat like earth is going around it in a circle like this. ठीक है? So whatever light is coming out from the sun in this orbit will fall upon this complete area, and a part of this area is getting consumed by earth, that we are not talking about. We are just talking about per unit area thing. So energy getting received per unit area per unit time will be equal to how much? That will be equal to power of this source, that is sun, divided by 4 pi r का square, where r is this orbit radius. ठीक है? So that same thing we are doing here. अब यहाँ पे आप values को put कर दो. I value is how much? 1400. P we don't know. 4 into 3.14 into 1.5 into 10 to the power 11. ठीक है? If you do this 1.5, this will be the square of this thing. If you multiply it, you will be getting approximately, power को आप ध्यान से देख लो, यहाँ पे 10 का power कितना जाएगा? 22, and this is I mean 2 more power, so that is 24 into if you see here, 1.5 will become 2.25 into 14 into 4, that is your 96 into 3.14. So if you see carefully, 96 approximately 100, not exactly, but approximately. And then in that case, power will almost reach up to 10 to the power 26. It feels like. So it is approximately equal to 4 into 10 to the power 26 watt. Okay, so this is what we are going to get. Now in the section B, what we have to do, assume that light coming from this source has a single wavelength. So we are assuming light is monochromatic, and that value, lambda value, is how much? 6000 angstrom. Estimate the number of photons emitted from the sun in 1 second. So how much photons are coming out in 1 second? So how much energy is coming out per second? 4 into 10 to the power 26 joule of energy per second. And in this much joule, how many number of photons will be there? So one photon meaning how much joule? That meaning hc by lambda joule. Put everything in SI unit. So h का वैल्यू आप क्या रखोगे? आप रखोगे 6.64 into 10 to the power minus 34. C is equal to how much? 3 into 10 to the power 8. Lambda will be how much? 6000 angstrom है, मीटर में चेंज कर लो. So this is this much. How much joule it will come out? Nearly so minus 10, minus 20, 4 it will become minus 24, and 8 you, if you will do, that will be minus how much? Minus 16, right? Again, 3 will go up. So 10 to the power 19, minus 19, right? So almost 3.32 into 10 to the power 19. क्योंकि देखो ये 6 से almost cut होगा, and then you will say approximately 3 into 10 to the power 19. But exactly if you will do, you will get this much. So this much joule. ठीक है, one photon is having this much joule, and total how many joule is coming out per second? How much joule of energy? 4 into 10 to the power 26. So I mean, if this much amount of energy, 3.32 into 10 to the power 19 joule of energy is coming out, then one photon is there. 1 joule mein how many photon will be there? 1 by 3.32 into 10 to the power 19. Just like in a childish manner, I am moving ahead because I really want each one of you to understand this thing, because this is very basic, and this you will encounter so often. And how much is the power here? Here the power is, I mean, that was 3.32. No, that is not. कितना था देखो, 4 into 10 to the power 26. ठीक है, so you just write it here. 4 into 10 to the power 26 के लिए कितना होगा? So 4 into 10 to the power 26 divided by 3.32 into 10 to the power 90. This will be the answer, right? So this will be approximately equal to how much? 10 to the power minus 19 is this one, right? Sorry, plus 19. This cannot be the energy of one photon. This is minus 19. So if it will go up, it will become 10 to the power 45. So approximately 1.19, or you can say 1 into 10 to the power 45. This is, so 10 to the power 45 number of photon will come out per second out of sun. Okay. Now what next we are getting asked? According to mass energy equivalence principle, estimate decrease in mass of the sun. ऐसे भी हम कहते हैं sun की एक life है. And why we talk about this? Because sun is spending itself for us. ठीक है. So we should really guard this earth very carefully, क्योंकि somebody is standing so far away, spending himself or herself, so that they can supply us with the energy, or he or she can supply us with the energy. ठीक है. So ये बहुत जरूरी है कि हम इस planet को बहुत ही beautifully और प्यार से रखें, क्योंकि कोई तो है ना जो खुद को खर्च कर रहा है हमारे लिए, and that is sun. So I mean, per second, how much mass of sun is getting spent in order to provide us with this intensity. ठीक है, that we are going to calculate. So देखो, mass energy equivalence principle we need to use, and we know that if we has mass m, we can convert it into energy equivalent to mc square according to Einstein theory that we have learned already. ठीक है, so this is this one. Now if you talk about 1 kg of mass getting spent, let's just take the example. So agar 1 kg hai, it means how much energy this 1 kg is providing. Let's talk about that one. So 1 kg ke liye energy kitna hoga? 1 into c ka square, that is 3 into 10 to the power 8 ka square. So that will give you how much? 9 into 10 to the power 16 joule. So if 1 kg is burning, then it will give us how much joule of energy? This much. Or you can say if 1 kg is getting spent, then we will say this much energy is coming out. Done it? But per second, how much energy is coming out? That was your 4 into 10 to the power 26 joule, right? So 4 into 10 to the power 26 joule of energy is coming out per second. So how much mass is getting consumed? So for 1 kg, this much energy. Done it? So this much energy means 1 kg, and 1 joule energy means 1 by 9 into 10, 10 to the power 16. So for this much energy, joule coming out per second, how much mass is getting consumed? 1 by 9 into 10 to the power 16 into 4 into 10 to the power 26. So this is this simple relation. And if you calculate it, 4 by 9, 10 to the power 16 से 24 cut करोगे, 10 to the power 8 into 0 point something you will be getting, right? 0.4 or something like this. So you can make it like 4.4 into 10 to the power 9 kg. Just imagine this much mass of sun, this much fuel is burning in order to provide us with that much intensity per second. Just imagine sun खुद को कितना खर्च कर रहा है, ठीक है? So we need to respect our planet and we need to be careful with our life, है ना? Because we are being provided with so much in order to live here on the earth. Let us respect that. I hope you have understood this question, and I hope there is no doubt. But in case you have, there can be, then you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.